We tend to view our modern civilization as a permanent fixture, but this world of steel and light is an ongoing performance, requiring the daily labor of billions just to hold nature at bay. If that labor suddenly stopped, the curtain would fall surprisingly fast. Without operators continuously delivering and feeding fuel into coal and natural gas facilities, the first stage of the blackout begins in a matter of hours. The machinery simply starves. Electrical grids are highly sensitive networks that require engineers to constantly match supply with demand. As isolated power stations drop offline, the remaining network experiences severe frequency fluctuations. This triggers automatic failsafes that shut down massive power corridors across the globe in a rapid cascade. The internet survives this initial wave only briefly. Data centers rely on backup diesel generators to keep servers running, but without refueling shipments, those reserves run dry within a couple of days, severing all digital connections. Our most globally interconnected achievement, the sum total of human knowledge floating in the cloud, relies entirely on a continuous, unbroken flow of electricity. Without it, the digital world vanishes completely in less than a week. Up on the surface, the immediate silence is obvious, but underground, a more destructive clock starts ticking. Coastal cities rely on massive, automated pumping systems to keep groundwater and ocean tides out of their transit networks. Without power, those pumps sit idle. Within days, millions of gallons of groundwater begin flooding the subway tunnels of places like New York and London, turning transit lines into subterranean rivers. This rushing water actively washes away the compacted soil and structural fill that support the heavy asphalt and concrete above. The ground itself hollows out. What began as a quiet electrical blackout quickly transitions into an unstoppable structural collapse as the very foundations holding up the modern world begin to dissolve. Fast forward about 20 years. Unrelenting freeze-thaw cycles have cracked open paved roads, allowing weeds and tree roots to tear the asphalt apart. Down below, the water-soaked steel columns supporting those subterranean streets corrode, buckle, and finally give way. Above ground, residential neighborhoods built with modern light wood frames succumb to rot and weather in a matter of decades. Even the towering steel and glass skyscrapers of the 20th century, compromised by flooded foundations and battered by unmitigated storms, eventually shatter and collapse into massive heaps of debris. The structures that actually endure aren't our technological marvels. Massive, heavy stone constructions, like the Great Pyramids, will continue to stand for thousands of years, alongside the thickest, most over-engineered stretches of concrete highway. Monuments carved directly into the Earth's bedrock are similarly stubborn, requiring the slow, gradual grind of geological weathering to smooth away their features. It is a peculiar irony of our engineering. The physical legacy we leave behind ultimately reverts to the basest, most primitive materials we ever used. Stone and concrete will outlast our steel and glass by millennia. Then there is the matter of our more volatile creations. Across the globe, hundreds of nuclear power plants require active, continuous cooling. Without maintenance, the water in their containment pools will boil off, leading to a series of intense nuclear meltdowns. This sounds like an extinction event, but the resulting radiation from these exposed cores is intensely localized and, on a planetary scale, relatively short-lived. We know this because we have already run the experiment. In the decades since the Chernobyl disaster, the irradiated exclusion zone has been almost entirely reclaimed by nature, turning the abandoned urban landscape into a thriving wildlife refuge. Our synthetic footprint, mountains of plastics, discarded circuit boards, and chemical waste, takes much longer to break down. Over centuries, these materials slowly fragment under UV radiation, eventually being buried under layers of new topsoil or colonized by specially adapted microbes. Our most dangerous poisons and stubborn polymers are a temporary hurdle for the planet. The broader biosphere absorbs the toxicity, adapts to the new chemistry, and moves on. Over the course of a few centuries, the concrete grids of our major cities are completely swallowed by vegetation, transforming into dense, vertical forests. The animal kingdom undergoes a harsh rebalancing. Highly specialized domestic breeds, Animals we genetically engineered to rely on us quickly perish. In their place, highly adaptable generalists and wild predators move in to navigate and hunt among the vine-covered ruins. With humanity gone, a massive ecological niche opens up. Through a process called convergent evolution, where unrelated species develop similar traits to adapt to their environment, entirely different animals will eventually evolve to fill our abandoned roles. Highly social, adaptable insects like ants and termites have existed for hundreds of millions of years. Given enough time, these colonies could expand to build complex agricultural societies that mirror the sprawling scale of our own. The disappearance of humans doesn't mean the end of global civilization. It simply clears the board, resetting the evolutionary stage for Earth's next dominant architects. Jump forward 1 million years. By this point, wind, rain, and tectonic shifts have scrubbed the surface clean. Almost all visible evidence that humanity ever existed is invisible to the naked eye. This geological cross-section shows our permanent physical legacy on the planet. We will leave behind a technofossil layer, a thin, distinct stripe compressed into the Earth's crust, made entirely of fragmented plastics, rare radioactive isotopes, and dense, concentrated metals. The Earth emphatically survives our tenure. Just as it fully recovered from the catastrophic Permian-Triassic mass extinction millions of years ago, the planet's biodiversity bounces back, completely indifferent to our absence. We tend to view ourselves as the protagonists of the planet. In reality, human history is just a brief, intense, and passing anomaly in the deep geological time of Earth. Earth easily survives humanity, but it cannot survive the inevitable evolution of the cosmos. This model of our solar system illustrates the ultimate astrophysical threat. In 1 billion years, the sun's luminosity increases 10%, boiling the oceans away. Then, in 5 to 7 billion years, it exhausts its hydrogen and enters a red giant phase, expanding to swallow the inner planets and melt Earth into cinder. Because the planet itself is ultimately destroyed, the only intact remnants of human existence will be the objects we sent far beyond the reach of our dying star, our deep space satellites. Probes like Voyager carry time capsule payloads, golden records holding the sounds, images, and coordinates of our species, designed specifically to outlast us. We were never the permanent masters of Earth. In the end, our ultimate legacy is a silent monument drifting endlessly through the interstellar void.